Hi everyone. In this video, I'm going to show you a bit about how to use our drug file editor for creating your own drug models for Tucuxi. What you will find on this page is two things that could be interesting. The documentation about the file structure, so what are the fields that are required and what is their purpose, and a short documentation about how to write such drug models. So what kind of information you have to get from a PK paper, for instance, and how to use that to build your own drug model. Then two options. You can start from a template or work on your own drug file. So first you will start with a template. So it will depend on the drug on the PK model you will be using. So that could be one compartment, two compartments or so. For instance, here, if I take a one compartment extra macro and I load the template, I end up with the model right here. And you will see some parts that are the history. So here you can add, for instance, the fact that you are creating the file and put your name, email, and so on. So we know who's been working on that right now. Then we have the header, in a sense, that describes a bit the drug in itself. So the ATC codes, list of active substances, name of the drug, description, and so on. And then a word about the study. So that's actually the paper, the PK paper you've been reading. So name of the paper, the study, the authors. And one good thing is to add the references. So here, if you click on this, that's something you have for a lot of these descriptions. So you can click and add something. So here I can append a reference saying, okay, that's a BibTeX or plain text. And then here I can write something in that. And then I can say OK for this. In a lot of parts of this editor, you can find comments. So here I can click on that and add a comment. A comment is basically some free text. So you are really encouraged to document as much as you can about, okay, for instance, I had this variability for that parameter because I found that value and I had to do some work around this, for instance. And for a comment to be valid, you need to add a language, because the idea that those files could be describing things in different languages. For now on, we just support French and English, so I would suggest to go for English for sure. And then the big part is actually the drug model in itself. You would have to put a drug ID, so that would be your drug name in lower cases. And what you see here, a lot of warning signs. Actually, if you click on the warning side, you have a message that lets you know what's happening. So here, the editor is not happy because we don't have a drug ID. It shouldn't be empty. And so if I put something right here, the warning will disappear. We have here the warning in drug models, just saying that a child is not validated, in the sense that if there is at least one warning within the drug model, then we will have this sign letting us know that there is still something wrong at some stage. Then you can describe your drug model ID. We'll let you respect the convention, like ch.tucuxi.drugid. First author name, followed by the date of publication. Then you can describe the model. So here the idea is to describe actually the population that is related to that specific drug model. So that could be adults in ICU, neonates, or stuff like that. And you can add some constraints. The idea of these constraints is to be able to say, okay, based on some covariates, I will add here, I can write some code that would allow some tools to detect that we are using that drug model for the wrong patient. So for instance, if the age is very important or you're working for neonates, it would be interesting to check that the age is smaller than 2 years, for instance. We'll have covariates here as well, so you will find it in your papers, what covariates are useful or not, so you can append the covariate. There are three specific covariates that we deal with a bit differently. That would be the sex, so you can just add sex as a covariate. And that's the same for the age, because we have to treat that a bit differently. It means that we'll have a birth date at some stage that will be translated into an age. So that could be in years, in months, weeks, or days. And the dose. In some models, we need the dose as a covariate. And else you can append a standard covariate. If I just show you the sex, how it looks like, we have an ID here, the name, that could be in different languages, some descriptions as well, and then the unit that could be empty, or we can just put an hyphen like this. Then the editor is happy, as you see. And that's a specific covariate, and it has a refresh period, which is when actually we need to refresh these covariate values if it's changing in time. So for the sex, obviously it won't change that much, but for some others like creatinine clearance, that could be quite volatile in a sense. So I would, but you need the refresh period for 1 day or 1 hour, for instance. We can add some validation of this covariate as well, because depending on the value of the covariate, then it will end up with PK parameters that are very wrong. We can add comments and so on. We then have the active moiety. You will actually have usually one active moiety medical drug, so you can put an ID, a name, the unit in which you want to deal with this, and a list of analytes. Usually it's the same as the active moiety. For some specific drugs would be different, but it's very, very uncommon. Then for most cases, the analyte will be directly used to compute, well, it's actually the same as the active moiety, so it's a direct connection here. You won't have to deal with that. But something important is the target, so you can append a target, or a target with a MIC, minimum inhibitory concentration if required. So if I can append a target here, I can select the type of target here, and then choose the unit, the minimum, maximum, best value, and a toxicity alarm, inefficacy alarm as well. Here, for instance, for the residual, if I write a unit being kilograms, that's all right. Actually, it shouldn't be all right, but it's one of the units that is available in the software. We are not checking that it should be specifically a concentration right here. And so I would put actually something like microgram per liter here. Then we have the list of analyte group. You will have just one analyte group. That's for some specific medical drugs. We need to be very generic. As an ID, I would suggest to use the same as the analyte itself. Then we have this PK model that should be the one you chose at the beginning when you started with this template. And then we can add the list of analytes. You will have just one, which should be the same as the active moiety. And basically what is important here is the error model. So that's the residual error model that you would find in the PubPK paper. So you can select what kind of model, and you can write actually the value of the standard deviation that you find. Then we continue with the PK parameters, the disposition parameters. Here we'll have clearance and volume, so it's already filled up a bit for you. So we have clearance, you can put a standard value between subject variability. So for instance, you can have a parameter that has a log normal variability. Then we have a warning because actually we should have standard deviation. And so for that, we can append standard deviations and write it here. Okay, we can have some validation that I think for that you can let the default values in this. One thing is that usually parameters, well, there will be some parameters that depend on covariates. So here, maybe I have the standard value, but then I can click on that to add some a priori computations. All right. And so here I can say, okay, maybe depending on the sex, so I can append an input. So I would take a covariate that I already have in my model. So the sex is the one I have. So here in the code, I could say if sex is more than 0.5, it means that that's a male. Then I could say the typical clearance is 15, and else typical clearance is 8, for instance, and then I can return this typical clearance. So that's a way of writing the a priori equations. All right, and here if you click on this sign, you will end up in the documentation that will help you because that's the tricky part, more or less. All right, so I have another parameter here, and if I continue, I have the list of formulation and routes. So usually there is just one formulation and route for one molecular drug, but still we should be able to add an extravascular route and an infusion one, for instance. So here we chose the extravascular model. We can select a formulation, could be a parenteral solution, and the route of administration, that could be oral, for instance. Then I can put a name here as the administration name with the idea of discriminating between different medical drugs with the same compound, I would say. Then I can enter some information about dosages. And for that, I need to identify the analytes I will have and convert actually the dose into an amount of analytes. So usually the factor is 1, meaning that it's just one analyte. For some specific drugs would be different. Then we can enter information about the available doses. So what unit we'll use, what is the standard default values, I would say. And then we can add some fixed values. You can click to add the values or add ranges. So here we have a range from 100 to 400 with a step of 100. We have the same for the available intervals. So here it's 12 and 24 hours. And if that's an infusion model, then there will be also the available infusion times for this. Don't hesitate to add comments to the dosages as well. And then we have the absorption parameters that are related to a group of analytes. That will be the analyte ID in the most common case. And then we have different parameters. So here we have F, the bioavailability, and Ka, which is the absorption constants. At the end, just time considerations. The idea is to enter the half-life of the medical drug and the multiplier that will be used to multiply this half-life to say, okay, we should reach steady state after that amount of time. If you enter wrong or too short values here, the editor will let you know that something bad happened. And then the outdated measure information, that's something that is actually not used yet in the software, but it's the idea of defining after what duration a measure shouldn't be considered. So if it's too old, it's not really meaningful for a posteriori computation. So that's it. And then if you're very happy and that you don't have that many warnings, or at least no warnings on values or units, you can check your file. Obviously here it goes very wrong because it's kind of empty. And here it's really starting some computation, and here we end up with a lot of warnings. I can show you what happens with a correct file. So I take the imatinib drug file. So here it loads all that, and so we can see here if I go, for instance, to the PK parameters. For the clearance, here we have, for instance, the equations defining the clearance, considering the 4 covariates. And here, if I do something wrong, like I'm changing the name of the variable here, and if I check the file, what will happen here is that it's telling me that something is wrong with that equation, saying that it's at line 20 here, and that there's an existing variable here. So it's just because I changed the name of this one, so theta 5 doesn't exist. And if I go back to correct that, here I'm modifying this. Okay. And then if I check the file again, that's great. It's green. It means that now the file is okay. I can save it. And so don't hesitate to save your file as often as possible because it's just on your web browser, and if you close it, you lose it. All right, so I can save it. And actually, the idea here is to save it within your folder or drug file that you have within your installation of Tucuxi. And if you put your file within this drug file folder, then if you reopen, so you start again Tucuxi, you should be able to see your own model. That's it for this short introduction, and I hope everything will go well. This editor is maybe not the best one, but that's the one we have that checks quite a lot of things, and there is a new one under development that will be ready pretty soon.